An interactive whiteboard (IWB), also commonly known as interactive board or smart boards, is a large interactive display in the form factor of a whiteboard. It can either be a standalone touchscreen computer used independently to perform tasks and operations, or a connectable apparatus used as a touchpad to control computers from a projector. They are used in a variety of settings, including classrooms at all levels of education, in corporate board rooms and work groups, in training rooms for professional sports coaching, in broadcasting studios, and others. The first interactive whiteboards were designed and manufactured for use in the office. They were developed by Park around 1990. This board was used in small group meetings and round tables. An interactive whiteboard (IWB) device can either be a standalone computer or a large, functioning touchpad for computers to use. A device driver is usually installed on the attached computer so that the interactive whiteboard can act as a human input device (HID), like a mouse. The computer's video output is connected to a digital projector so that images may be projected on the interactive whiteboard surface. The user then calibrates the whiteboard image by matching the position of the projected image in reference to the whiteboard using a pointer as necessary. After this, the pointer or other device may be used to activate programs, buttons, and menus from the whiteboard itself, just as one would ordinarily do with a mouse. If text input is required, the user can invoke an on-screen keyboard or, if the whiteboard software provides for this, utilize handwriting recognition. This makes it unnecessary to go to the computer keyboard to enter text. Thus, an IWB emulates both a mouse and a keyboard. The user can conduct a presentation or a class almost exclusively from the whiteboard. In addition, most IWBs are supplied with software that provides tools and features specifically designed to maximize interaction opportunities. These generally include the ability to create virtual versions of paper flipcharts, pen and highlighter options, and possibly even virtual rulers, protractors, and compasses, instruments that would be used in traditional classroom teaching. Running software that is loaded onto the connected PC, such as a web browser or other software used in the classroom. Capturing and saving notes written on a whiteboard to the connected PC. Capturing notes written on a graphics tablet connected to the whiteboard. Controlling the PC from the whiteboard using click and drag, markup which annotates a program or presentation. Using OCR software to translate cursive writing on a graphics tablet into text. Using an audience response system so that presenters can poll a classroom audience or conduct quizzes, capturing feedback onto the whiteboard. In some classrooms, interactive whiteboards have replaced traditional whiteboards or flipcharts, or video media systems such as a DVD player and TV combination. Even where traditional boards are used, the IWB often supplements them by connecting to a school network digital video distribution system. In other cases, IWBs interact with online shared annotation and drawing environments such as interactive vector-based graphical websites. Brief instructional blocks can be recorded for review by students. They will see the exact presentation that occurred in the classroom with the teacher's audio input. This can help transform learning and instruction. Many companies and projects now focus on creating supplemental instructional materials specifically designed for interactive whiteboards. Some manufacturers also provide classroom response systems as an integrated part of their interactive whiteboard products. Handheld clickers operating via infrared or radio signals, for example, offer basic multiple choice and polling options. More sophisticated clickers offer text and numeric responses and can export analysis of student performance for subsequent review. By combining classroom response with an interactive whiteboard system, teachers can present material and receive feedback from students in order to direct instruction more effectively or else to carry out formal assessments. For example, a student may both solve a puzzle involving math concepts on the interactive whiteboard and later demonstrate his or her knowledge on a test delivered via the classroom response system. Some classroom response software can organize and develop activities and tests aligned with state standards. Please subscribe, like, share, comment and click icon for upcoming videos.